Okay, so in this short video, we just want to talk briefly about how databases are organized within themselves, and we're going to talk about 4 key terms that are very important you understand. They always come up in exam questions. They are table, record, field, and fact. And then finally, we're going to just briefly discuss what the term relational databases means. So in our school example, we discussed that we can store data on pupils, teachers, and classes, etc. So in the database world, we call these things, these teachers, pupils, and classes, we would call these entities. This is what we are going to try and model. This is what we're going to try and record in our database. So within a database, each group of entities, so pupils for instance, is stored in a structure called a database table. Okay, so a table has entities. You can imagine a table holding a list of pupils. So a table has rows, and each row is a record. And a record describes a single pupil. So again, you've got a pupils table that has lots of rows, and each row is an individual pupil. A table also has columns. Okay, so rows go from left to right and columns go from top to bottom. And a database table is the same. It also has columns, and each column is called a field. So that describes an aspect of an entity that's applicable to all the entities. What that means is that if you take a pupil, which would be an individual row, then that pupil is going to have lots of different columns, maybe a name, an age, a date of birth, form, address, etc., etc. And each one of those is called a field. And then where we have a row and a column meet, where they intersect, that is known as a fact. Okay, so we have tables, records, fields, and facts. Now graphically, it looks like this. So this whole thing here is a table, and this is our teachers table. So this is holding information about teachers. And we can see that we've got one row, well, we have 4 rows in total, but this one row here is all about just a single teacher. So we don't split teacher data over 2 different rows. So we have one row that's all about an individual teacher. And then we can see in our columns, so here we've got a subject column. This is the data that is applicable to all teachers. So John teaches maths, Sarah teaches English, Iman teaches maths, and Yasmin teaches English. Every teacher has a subject, and this column here is called the field. And where a record and a subject meet, this is called a fact. So the fact that John teaches maths is represented here. So when you were looking at that table, you might have been thinking to yourself, hang on a second, that looks a little bit like a spreadsheet. What's the difference? Okay, so spreadsheets have worksheets, sometimes called sheets. They have rows and they have columns, whereas databases have tables, rows, and columns. Okay, and at first glance you may think they look very similar, and you're probably right, they do look very similar, but there are some differences between the two of them. So a spreadsheet is only designed to store data in one sheet. It's not really designed to be pulling data together from all over different sheets. Modern spreadsheets can do that, but in general they are designed to have a single sheet, a 2-dimensional table layout. Whereas databases are designed to store data in lots of different tables, and we'll talk about that in a couple of seconds. Okay, so spreadsheets store data in a single sheet. Databases store data in multiple tables, and that's the first big difference between the two. The second big difference is that rows and columns in a spreadsheet can store any data. You don't have to follow a pattern. So you might have name followed by age, and then on the next row you could have address followed by date of birth. Doesn't matter. Okay, the spreadsheet will still work. Databases, on the other hand, are very structured. Each table has specific columns, and that column can only store one type of data. And then finally, we say, because spreadsheets are designed to store their data in single tables, they are known as being non-relational. Whereas databases, because they store data in lots of different tables, are usually relational. Now, I say usually because there are some types of databases which are not relational, but they don't fall into the scope of what we're looking at. So I've used this word relational a few times. Let's just understand what it means. So relational means you're going to store data in separate tables, whereas non-relational means to store data in a single table. So here's an example. Let's think that we're talking about a fruit shop and it's storing its data, storing its orders in a non-relational spreadsheet. Okay, so it's a fruit shop, it's got a spreadsheet, and it's just every time it has an order, it just writes down the order so it knows how to fulfill them at the end of the day. Now this is what that spreadsheet might look like. You might have an order ID, a product, what that person's buying, who the customer is, and the delivery address. Okay, so this bill here, he's bought apples and oranges, and that delivery address is going to 123 King Street. Okay, so this is the same guy buying two things. Then you've got Joe, who's just buying oranges and lives at Villa Compound, and then you've got Siraj, who is just buying kiwi fruit and lives at Rose Tower. Okay. Then Bill phones the shop and says, by the way, I've moved to 34 Python Way, but I haven't told you. Can you update your systems, please? Right. So what has to happen next? Okay. What you have to do now is go through your non-relational data, and every time you see Bill, change it from 123 King Street to 34 Python Way. Okay. So this is we'd have to do two different writes here. We'd have to change this one, then we'd have to change this one. So even on a small change, a small set of data like 4 rows, a simple change like that means we have to do 2 writes. So you can imagine if we've got millions of rows, let's imagine this is all of the orders for Bill through the year, and Bill isn't just a person, he's a major supermarket chain. Having to go back and change each one of those delivery addresses would be a problem. Now, a relational database stores its data in separate tables. So here we've got 2 different tables. Our first table is of orders. So this is one order, order 2, order 3, order 4. And then our second table is of customers. So Bill lives at this address, Joe lives at this address, and Siraj lives at this address. When Bill phones the shop to say, I've now moved to 34 Python Way, the only place we need to change is here. So even if Bill has millions of orders, we're only going to make one change in this table here. And then when I want to produce a list of orders, I'll merge these 2 tables together using the existing data, and that'll give me then the latest version of all of the data that we've got. So straight away you can see that storing data in this kind of relational format means that updates and changes are much, much faster, because you only need to change data once rather than once per line of code in the non-relational database. Okay, now one thing to recognize is that although relational databases are much faster to update, every time we want to read or merge 2 tables together, we have to do an extra operation. So whereas with a non-relational database, we can just read each line of data and pull it out, with a relational database, we have to merge these two tables together and then read them and put them out. So in fact, the approach that is the slowest to read from is a relational database. And this is why we still have that mix. So if I have a database that is being changed very often, I'll use the relational database. If I have a database that is being read more often, I'll use a non-relational database. But for the sake of our exams, every database we talk about will be relational databases. Okay, so I hope that covers relational databases. I hope you found that useful. As always, let me know if you don't.